Chapter 2 is solving equations. Big ideas have to do with using addition, multiplication, and distributive properties, simplifying variable expressions, solving equations using mental math, solving equations using addition, subtraction, multiplication, and division, and solving equations with decimals. Section 2.1 is properties and operations. I can use properties of addition and multiplication. In English, the word commute means to change locations. So if you commute to work, for example, in Fargo, you change from Lisbon to Fargo. An associate means to group together. A lot of times you'll hear like law firm and associates, or like the people you associate with are your friends, they're your group. These words have similar meanings in mathematics. Commutative properties let you change the positions of numbers in a sum or product. Commutative let you move. Associative properties let you group numbers in a sum or product together. They let you change the group. So again, our commutative properties let us move things. They let us do them in any order. So the commutative property of addition says, in a sum, we can add numbers in any order. So as long as all we're doing is adding, we can do that in any order. So we can take 4 plus -7, or we can take -7 plus 4. Either way, we get to the same spot. And in algebra, it's a plus b equals b plus a. The commutative property of multiplication says in a product, or things that are multiplied together, we can multiply numbers in any order. So we can take 8 times -5, or we can take -5 times 8, and it gets us to the same spot. In algebra, we can take a times b, and that equals b times a. The associative properties of addition says changing the grouping of the numbers in a sum does not change the sum. And the associative property of multiplication says changing the grouping of numbers in a product does not change the product. So it doesn't matter which order we add or multiply in, or the grouping. Remember, PEMDAS says that we have to do grouping symbols first. So it doesn't matter if we have 9 plus 6 in our grouping, or 6 plus 2 in our grouping, as long as we're adding all the same numbers. Just like it doesn't matter if we take 3 times 10 first and then multiply by 4, or if we take 10 times 4 first and then multiply by 3. Order doesn't matter, and our group doesn't matter, as long as all we're doing is adding or all we're doing is multiplying. In example 1, it says you buy a portable CD player for $48, rechargeable batteries with charger for $25, and a CD case for $12. Find the total cost. Well, here's a little spoiler alert. Total in math means we add them all up. So I'm going to take my CD player plus my batteries plus my case to get my total cost. Now, we know what some of those things are. We know our CD player is $48, and we know our rechargeable batteries are $25, and we know our case is $12. And again, we're still just adding them up to find our total cost. Now, if we look here, we can probably add 48 and 25, but if we notice, 48 and 12 are going to add up to have a 0 in the ones digit, and that's going to be a little bit easier to do. So I'm going to use my commutative property of addition. I'm going to move these two pieces, these two terms. I'm just going to switch their spots. So instead of having 25 plus 12, I'm going to have 12 plus 25. And again, I didn't change anything else. I still have 48 plus 12 plus 25 equals my total cost. So the same players in the game, same pieces, I just moved them around. Now what that lets me do is 48 plus 12 I can do in my head. The 2 more for my ones digit make 50, plus 10 gives me 60. And I still have that 25 here. Now when I take 60 plus 25, it's a lot easier to do in my head, and I get 85. And this is in dollars. So sometimes it makes it a little bit easier for us. We could have gone 48 plus 25 plus 12 and gotten to the same spot, But if we move those pieces around a little bit, it makes the problem just a little bit easier for us. Here we're going to evaluate 4xy when x is negative 7 and y is 25. So I know what x equals. X is negative 7. So everywhere I see an x, I'm going to plug in a negative 7. And I know what y equals. Y equals 25. So everywhere I see a y, I'm going to plug that in. So I still have a 4. My operation here, when there isn't one shown, is multiplication. So I see an x, which we said was negative 7. And then I see a y, which we said was 25. Now, using my commutative properties again, I can move a couple of these around. If I look, I know that 4 times 25 is 100, just like 4 quarters gives me $1. So if I move these two, it makes it a little bit easier. Otherwise, we multiply left to right, and I have to take 28 times 25, and that one gets a little bit trickier. So here, if I move those pieces, I still have 25 times negative 7. It's just in the other order. Now that 4 times 25 I can do, I know that's 100. Just like 4 quarters gives me 100 cents or $1. And I still have that negative 7 here. Now my signs are different. So I'm going to have a negative answer. 7 times 100 is 700. So again, we still could have gotten there by taking 4 times negative 7 times 25, but maybe not in our head the same way that we could do this, or maybe not as easily on pen and paper as we could here. So it's a little bit work smarter, not harder there. Feel free to pause here and give these a try. I'm going to go ahead and use my properties here. My associative property says that I can group them in any order. What that also means is I don't even have to have groupings if I don't want to. So I'm going to take away my parentheses here. I don't want to have a group yet. So I still have 17 plus 36 plus 13. And that works as long as the only thing I'm doing is adding or the only thing I'm doing is multiplying. Now, if I move my 13 and my 36, I know that my ones digit, 3 and 7, are going to add up to a 0, and that's going to be a whole lot easier to add. So I'm just going to rewrite it with those two swapped. I'm going to move the 13 and the 36. I didn't change where my 17 was. I didn't change that I'm adding. All I moved was the 13 and the 36. Now, according to PEMDAS, we add left and right. Left to right. So I can take 17 plus 13 and get 30. The 3 onto the 17 makes 20, and then I have that extra 10. I haven't changed my 36 yet. And now finally, I can go ahead and add those up, and I get 66. Please make sure you show your steps on these. In the book, they write out the name of the property every time. I'm cool if you just show it. So I showed using my associative property, my commutative property, both of addition there. Again, feel free to stop and give this a try if you'd like. Here, I can take 8 times negative 3 if I want to, but if I take 8 times 5, that's going to end in a 0. So I'm going to move these two pieces. I'm going to swap my 5 and my negative 3. And I'm still multiplying by that 8. We use parentheses to show multiplication here, but you could use the dots or the time symbols or however. 8 times 5 gives me 40. And I'm still multiplying by that negative 3. That hasn't gone away yet. Now, my final step, I have 1 negative. 40 times 3, 120. So negative 120. Feel free to pause here and give it a try if you'd like. So again here, we can see that if we add up the 4 and the 6 in my decimal places, that's going to give me a whole number. So I'm going to go ahead and commute and move my last two terms here, my last two numbers. So by doing that, all I do is I move my 7 and my 0.6 and my 9.7. I didn't change my 3.4 or the fact that I'm adding. Now what that lets me do is it lets me add, and my 4 and my 6 here in my decimal places add up to give me a whole number, a 1, plus my 3 plus my 7 gives me 11. And now I bring down the rest of it. So I'm still adding that 9.7. I can go ahead and do that now. 11 plus 9 gives me 20, and then I still have that 0.7 as my decimal place. Again, feel free to pause here and give this a try if you'd like. First off, we know what x equals. X is negative 6, so everywhere I see an x, I'm going to make it negative 6. Y is 20, so everywhere I see a y, I'm going to plug in a 20. So here I have 5. Then I see an x, so I'm going to plug in the negative 6, which we know. That's still squared, and again, my operation is multiplying. My y is 20. PEMDAS says we have to do parentheses first, so I'm going to go ahead and do that. Negative 6 squared is the same as negative 6 times negative 6. And negative 6 times negative 6, two negatives make a positive, 36. And I didn't do anything with my 5, and I didn't do anything with my 20. Now if I look though, I know that 5 times 20 is 100. So I'm going to do those two first. And in order to do that, I need to commute. I need to move two pieces here. So I'm going to take 20 and then times 36. But I still have my 5 there. So 5 times 20 is going to give me 100. Still times that 36. It's going to give me 3,600 or 3,600. Here I'm trying to simplify the expression, but PEMDAS says I have to add from left to right. So it wants me to add x plus 3. I can't do that until I know what x is. So instead, I'm going to use my associative property, and I'm going to group my 3 and my 6 together. What that lets me do is it lets me add that and get a 9. And I haven't changed that x or the fact that I'm adding, but there's nothing else I can do here to simplify that. So my only option there is x plus 9 using that associative property. In 4, same idea. It wants me to do PEMDAS first, which means I need to multiply 8 and y, but I don't know what y is. So instead, if I get rid of my parentheses, now I have 4 times 8 times y. PEMDAS says we multiply left to right, so I can go ahead and multiply. And I stop here because I can't multiply times that y until I know what it is. So feel free to pause here and give 5 a try if you'd like. Here, we're going to have to use our associative property again and group these two because we can't add m plus 5 like PEMDAS wants us to do first. When I add those, I get 14. I didn't change my m or the fact that I'm adding, but right now there's nothing else I can do because I don't know what m is. In 6, I can't take 3 times k until I know what k is, so I'm going to drop my parentheses there, which means I just grouped it differently. I grouped it so that it's not grouped, which is still our associative property. Now, PEMDAS says we multiply left to right. 6 times 3 gives me 18, and I'm still multiplying by that k. There's nothing else I can do to simplify there. Feel free to pause and give this one a try. So I can't add 4 plus x until I know what x is. But if I commute these two pieces, and I take -1 first, and then the x, I didn't change my 4 or the fact that I'm adding. Now I can add up my number parts, according to PEMDAS. Add left to right. 4 plus -1 gives me 3. I didn't change my plus or my x, and I can't. There's nothing else I can do there until I know what x is. In 8, it wants me to add 2 and r, but I can't until I know what r is. So I'm going to change my grouping here. I'm going to take 2 times r times -5. Now, I still can't take 2 times r, but if I commute and move these two pieces, now I can take 2 times -5 and get -10r. And that's everything for the first half of section 2.1.